Hello everyone, welcome to Institute Palm the Chemistry Genius. Today we'll discuss Rimer-tiemann reaction and the mechanism of Rimer-tiemann reaction with both ortho and para products. So the formulation of the phenol by the reaction with chloroform in strong acid aqueous sodium hydroxide is known as Rimer-tiemann reaction. So if you have a phenol and then if you react with chloroform, okay, that is called your formulation, and you react with sodium hydroxide, strong sodium hydroxide at a higher temperature, you get sodium phenoxide with an aldehyde group added to the both ortho and a para position of the ring. Okay, so this product, now what happens is that this intermediate, if you hydrolyze it with water molecules, okay, so if you do hydrolyzation, what will happen is that sodium ion will go replaced by hydroxide ion hydrogen, and it will give you 2-hydroxybenzaldehyde and your 4-hydroxybenzaldehyde. So these are the two products. Okay, so 90% is your 2-hydroxybenzaldehyde. Why? Because there is an intramolecular hydrogen bonding, whereas your trans product is your only 20%. Why? Because there is no intramolecular hydrogen bonding. Now see, there is one important exception, like if ortho position is blocked, अगर ortho position में कुछ और group हुआ, like OCH group, it is blocked, then your para position will be your major product. Okay, so again, if you just react with chloroform and sodium hydroxide, you are going to get your CHO group added to the para position after hydrolysis. So that is your Rimer-tiemann product. Let us go to the reaction mechanism and see how CHCl3 transfers itself to CHO group and gets added to the you can say the benzene ring. Okay, so that is your mechanism of Rimer-tiemann reaction. The first step is that this OH minus ion which is there in the reaction medium, okay, so this is a base catalyzed reaction again, so it will take a proton from CHCl3 and there is a dichlorocarbene intermediate formed by the removal of Cl minus ion. Okay, so this is a dichlorocarbene, it is a 6 electron system and it is very much reactive. Okay, now see what happens is that this phenol, okay, again there is OH minus ion which will take up the phenoxide ion, that means it will take up hydrogen from the phenol ring, and then you will give you a resonance stabilized phenoxide ion. Okay, so see here, this is the resonance goes like this, it takes up hydrogen and then O minus will come into the ring, then the minus comes into the first ortho position. Now again it goes to the para position by the arrows it is shown. Okay, so I will be discussing about the resonance in some other video, so you know how to make resonance. Okay, so now you are going to get your phenoxide ion which is very much stabilized. Okay, now this phenoxide ion, now the dichlorocarbene will go and act to the medium. Okay, so the O minus will come into the ring and now this electron goes and now Cl2 gets added to your ortho position. Now there is hydrogen in ortho position, then because there is a minus sign, okay, so minus sign, it will try to take up again a proton, it will take a proton from the system itself intramolecular, so again now you are going to get your CHCl2. The third step is that hydrolysis. Okay, so the OH minus ion again replaces the chlorine ion, as chlorine ion very much it is a bigger in size and it's a very good living group. Okay, so it will leave, बहुत जल्दी वो leave कर देगा and you are going to get your OH OH ions in the place of chlorine ion. Now the removal of water molecule from this molecule gives you your product. Okay, again there is a water is there, so proton is also there, so you are going to get your ortho hydroxybenzaldehyde. So, okay, so intramolecular hydrogen bonding, 2-hydroxybenzaldehyde is formed. Now the trans product, if you see, the step will be the same. The first step is again same, this OH minus will take up the proton, there is a then you have a dichlorocarbene intermediate formed by the removal of again chlorine atom. Okay, the minus sign will come up and the one chlorine atom will leave, giving you dichlorocarbene 6 electron system. So this is very much reactive, it has too much of electrons. Now what happens, there is again OH minus ion. The second step, what will happen, again this OH minus ion will take up the proton from your phenol molecule. Okay, so again you are going to get a phenoxide ion which will be again resonance stabilized as the same I have shown for the first one. So resonance stabilized phenoxide ion. Okay, now what happens is that this phenoxide ion, just because it is resonance stabilized, okay, so there is tendency to form ortho and para position again, but this time we will go for para product. So okay, so now again this dichlorocarbene, the step 3, it will come into the picture. So the phenoxide ion will take up CCl2, okay, minus, now this will shift into the para position. See, I have just changed the position of the arrows and then you are going to get your para product. बस आपको arrow का जगह change करना है. There is nothing difference in that. The way we had done for ortho, it is same. Again this one, this minus sign in the carbon atom will take up the proton again. Now it is going to give you your phenoxide ion with CHCl2 added to the group. Again hydrolysis, this will OH minus will take the place of chlorine, because chlorine is a very good leaving group, it will leave the molecule easily, okay, giving you this OH, 2 OH group in the presence of, in the place of chlorine ion. Now what happens again, there is a removal of water molecule very easily. जब भी this kind of molecule is there, unstable diols are there, water molecule बहुत easily release हो जाता है, and then you are going to get your 4-hydroxybenzaldehyde. Thanks for watching, and do watch other videos so that you get overview of your the subject, and mostly I will tell you, please do write it down whatever I have given in the video.